Hello everyone. In this video I will explain some things to you about functions. To start off we will have a look at what functions even are and also why would we use functions. After that I will give you some examples of working with functions and I will end with a few specific types of functions. Since this is going to be quite a lot of information with quite a few new terms, I'm going to end with a summary, basically a word list of the new terms that have been used. So to start off, what are functions? Now before I get to actual functions, I'm actually going to start with having a look at formulas. So let's say we have the formula y equals 3x plus 7. Now I can think of this formula as some sort of machine, some sort of magical box. I put a certain x in, magic happens and a y comes out. I could give this box a name, I could give this machine a name. Let's say I call it f. And what this specific machine does is going to depend on the x that I put in. So let's put that over there. And then I can say that my box fx does 3x plus 7. Fx is 3x plus 7. We then say that f is a function of x. It does something depending on what x is. Now also because my answer, y, depends on what x is, we call y the dependent variable. And as x is the variable that we change around to get different values, we call that the independent variable. So the independent variable is the one inside the formula and y is the result. So that's a basic idea of what functions are, but why would we use functions? There's a couple of reasons for this. Some of them will be useful now, some of them will become useful later. I will start with the ones that are most useful now. And the most obvious one is naming formulas. If you have multiple formulas, it is easy if you can say, yeah, this is f, this is g, this is h, and separate them like that. So that is just a very simple purpose. It also turns out to be very practical notation. You can say calculate f of 4, or you can say solve fx is 4. We're going to look at those examples in a moment when we look at how to work with functions. Then, this is not very useful now, but it gets more useful later. It allows you to specify what the independent variable is. This sounds very vague, but we've already had formulas like y equals ax plus b. Here x is the independent variable, and a and b are numbers that you just still have to fill in. And you can make that more clear by writing it as fx equals ax plus b. Then you say x is the independent variable, the others are just things to be filled in. Last but not least, and this is not going to come up anytime soon, but there are functions that are not formulas. And, well, then we are definitely going to need a new way to denote that. An example would be this. There is no one formula that describes this whole graph. But that is not important now. All right, so let's get to working with functions. And let's get back to that practical, efficient notation. So let's get back to that function we just had, fx equals 3x plus 7. The example I mentioned was calculate f of 4. What that simply means is fill in 4 as the independent variable, fill in 4 for x. So that means we calculate 3x, so 3 times 4 plus 7, and we can get our answer of 19. This is more efficient than asking what is y when x is 4. So it's simply efficient notation. There's also some new terminology to then give your answer. Because this 19 has a name, we call it the image at 4. More generally, the image is any result you can get. So specifically, 19 is the image at 4. That is the first thing we can do with functions. Second example I already mentioned was solving. Solve fx equals 4. Now solving again works just like you're used to, but now we write 4 instead of fx. So we get 3x plus 7 equals 4. I'm not going to get into how to solve it, but if you want a reminder of that, just have a look at my video on solving linear equations. But we can just get the solution x equals -1, just as we would solve any other equation. Last but not least, just like we can plot formulas, we can also plot functions. And again, it just works the exact same way. We make a table again. The only difference is that we don't write x and y, but x and fx. And we calculate fx for a couple of different values. We've already seen that f of 4 was 19, but we can do that with any different number. If x is -2, we do 3 times -2 plus 7, and we get 1. And in that way, we calculate all the different numbers. And we can just plot these points into a coordinate system to get our graph. Important to note here is that on the axis, you still write x and y, because the coordinate system works for any function. It's not specific to fx. To specify that this specific line is for fx, we can add a little f here. But just like this, we can plot any function. So these are some ways we can work with functions. Now, last but not least, let's have a look at a few different types of functions. Now, one nice thing with functions is we can plot many of them in the same coordinate system, and we can specify which one is which by their letters. I'll be mentioning here what specific type of function each of these graphs are. I will also mention the specific function for this specific graph, but that is not relevant. It's important to know what type it is. So starting with f, the green one, that's the one we've already seen. That's a linear function. It's a straight line, and in this case, it's the one we've already seen. It's fx equals 3x plus 7. The second one, g, we see it's a parabola, and the parabola means we've got a quadratic function. So there's a squared somewhere in the function. Specifically, this one is gx equals x minus 2 squared. Next up, we get to h, and h stays the same throughout. It's a constant function. It's a horizontal line. And that gives a very easy function, in this case hx equals 10. And last but not least, we've got j, the blue one, and that one goes up more and more steeply. That is an exponential function. And the specific function for this one was j of x is 2 times 1.5 to the power of x. So it's exponential because x is in the exponent. So these are the 4 types of functions you should be able to recognize, both from the formula and from the graph. To finish up, let's do a little summary, a little word list. So starting off with function. A function is a new way to write down a relation, a formula. For now, it will always be a formula. And we write f of x, g of x, h of x. Any letters, usually we start with f. And we then say that f is a function of x, if we want to put it into a sentence. Next up, we have the term independent variable. This is the variable that changes in a function, the variable that you play with. Usually this is x. It can also be t if it's about time, or it can be any other letter really, but it's the one that's inside the function. There's also then the dependent variable. That's the variable that changes depending on the independent variable. It's usually y, but again, can also be a different letter. And on this topic, last but not least, we have the image. And the image is the result of a function when you fill in one or more numbers. And then let's have a quick recap of the different types as well. So first of all, we have a linear function, a function of a linear relation will give you a straight line. Then there's also the quadratic function. It's a function for a quadratic relation. It's going to have a squared in your formula and it will give you a parabola. Then there's a constant function, which, as by now you might have guessed, is a function for a constant relation, and it will give you a horizontal line. And last but not least, the exponential function, a function for an exponential relation, where the independent variable will be in the exponent. That is all I have to say for now about functions. I hope this helped you understand a bit about what functions are and about dependent and independent variables.